Hello, this is one in a series of short videos about interfacing with an ONTAP cluster. Or in other words, what ways are there to communicate with the available shells and tools to manage your clusters. This one's on the Systemshell. But before we start, there are some remarks of NetApp on using the Systemshell as a mere mortal. Under normal circumstances, Systemshell should not be used without directions from NetApp support. The Systemshell is a low-level shell that is used only for diagnostic and troubleshooting purposes. So why then are we going to inspect this shell if NetApp clearly discourages it? Well, there may come a time that you have to enter it under NetApp guidance, of course, and perform some troubleshooting in it. So it might be a good idea to at least have a look at it, maybe even experience some interesting stuff that sheds some light on how an ONTAP node functions. And if you're eager to do so but hesitant because you don't want to wreak havoc to your production environment, simply download the simulator and you can break that as often as you like. And we'll also see what the Systemshell is related to other shells. Then we'll set up access to the shell. And finally we will log in and have a good look around. Some things may surprise you and maybe even bring a smile to your face. And again, the simulator is a safe way to explore whatever you want to explore. Now, what is this Systemshell really? Every cluster has two local shells per node and a single cluster shell which runs across all of the nodes. So whatever you do in any of the local shells stays on that node. This doesn't mean that it cannot affect the cluster as a whole if you're not careful. One of these shells is the node shell, which will give you access to things that have to do with the local node. Basically, this shell is also referred to as the 7-mode shell, because before ONTAP existed as it does now, there was something which is now referred to as the 7-mode version. We're not going to go into the node shell here because this is about the Systemshell, and we will leave the node shell for what it is. The other local shell is the Systemshell indeed. As mentioned, this shell is not for day-to-day operations but for troubleshooting and diagnostics. NetApp has decided that only the diag user can access this shell, and the diag user by default is locked and also has no password. When you unlock the user and want to log into the Systemshell, you will need to set up a password first. So let's do that. So we first check whether the user is locked, and we see that it's locked, so we unlock it. And after that, we need to set the password, so we do that as well. And then we try to connect, but not from the admin mode. We have to change to the diag mode in order to be able to log in to the Systemshell. And again, we see a warning, so we need to be careful. And our first command will be the ID command to determine who we are, and as we expected, we are diag. But if we wanted to, we could become root. But we don't need to now, so we switch back to diag again. Now our current directory is the diag's login directory, but when we list the contents of the root directory, we see loads of interesting directories. I've picked out a few interesting ones we'll have a closer look at. As you may have noticed, this is a Unix environment. To be precise, it's FreeBSD. And to prove that, we go to the compact flash card, which is our boot device. And in the x86-64 directory, we detect a FreeBSD directory. And when we list its contents, we see the image1 directory. Actually, this is where the kernel and other relevant stuff like kernel modules live. There's only one image1 directory, as we can see. If we would upgrade this system, there would be an image2 directory that would contain the newer version. So actually there's room for two versions of the operating system. And every time you upgrade, the current version will become the old version and the new version will become the current one. Also, the var file system is located in the compact flash as a zip tar file. At boot time, it will load this file system into memory. So let's have a look at that first, because there is a really interesting little file in there. As expected, the var file system is accessible via /var. Now, for the interesting file, we need to cd into the rdb directory, and this contains the site list file, which informs the node of some important configuration data, like what is the node's ID, how many nodes are there in the cluster, what is the name of the cluster, and other stuff. And we see that this cluster contains two nodes and the information will be the same on the second node. So this kind of explains how a single node at boot time can determine to which cluster it should connect and what are the other nodes in the cluster. And finally we go to /mroot, which actually is vol0. And as you probably know, vol0 is the volume that contains all configuration and logging and more that has to do with the cluster at the cluster level. So we could, for example, get all of the log files from here if we liked. And again, you don't really go here at any time except when the cluster or node is in trouble. And you may find some useful information in this shell, maybe. A nice thing to do is go back to the cluster shell from this system shell without exiting. Simply start the next generation shell, which is actually the cluster shell. So we're back in the cluster shell and can run cluster commands. And then we exit and we're back in the system shell. And if we would write some shell scripts in here, we could use the -c option to run commands from the script to be executed in the cluster shell. And again, in production environments, it's not a good idea to play around in this shell. So we leave it the way we found it, and we're done.